All right, welcome back. In this screencast, we take a look at regular polyhedra. Now that's two vocabulary words that we've now put together in uncomfortable ways. Regular means that all the sides and all the angles are congruent, and with a three-dimensional figure, that's all the dihedral angles are congruent. So that's like a big deal. All the faces are congruent. All the dihedral angles are congruent. All the sides of all the faces are congruent. All the angles in all the faces are congruent. That's dicey. And then polyhedra, well, those are three-dimensional shapes where there are faces all the way around. So what do those look like? Well, it turns out there are only 5 in the world. They are the 5 Platonic solids. You can Google it, Bing it, whatever is popular when you watch this video in a bunch of years. There are only 5 Platonic solids in the whole wide world, and these are they. Some of them are very familiar to children. The cube is very familiar to children. Squares all the way around, so all the sides are congruent, all the angles are congruent, all the dihedral angles are congruent. It's a cube. It's very familiar to a child. Tetrahedra are also very familiar to children. They call them triangle dice. That's just not a thing. They are tetrahedra, but it's really hard for a 5-year-old to say. There are 3 others. There are octahedra. Octahedra have 8 triangular faces. There's the dodecahedron with 12 pentagonal faces. And then there's the icosahedron with 20 triangular faces. Octa is 8, dodeca is 12, icosa is 20. And you can see the nets for each of those. The nets for each of those show us how to unfold the three-dimensional shape, or how to fold the three-dimensional shape. With a tetrahedron, it's just 4 equilateral triangles, and you can imagine well how things fold up to give that shape up there. The net is 2-dimensional. The net for a cube has to look like this, and everybody at one time or another has had to take something like this and fold up all the faces and get themselves a cube. Similar nets exist for octahedra and dodecahedra and icosahedra. Each of these nets can be folded up to approximate, well, to create this three-dimensional figure that we see. Now, you might wonder, how do we know that these are the only 5 in the world? How do we know that you're not going to find a 6th one and become super world famous overnight by finding a 6th one? Well, because we know from a guy named Leonard Euler that V minus E plus F is 2 for any potential Platonic solid, any potential regular polyhedron, where V is the number of vertices, and E is the number of edges, and F is the number of faces. So, for example, with the cube has 1, 2, 3, 4, 5, 6, 7, 8 vertices, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges, and 1, 2, 3, 4, 5, 6 faces. And that does equal 2. So in the case of the cube, vertices minus edges plus faces is 2. It has to go that way if there's going to be any sort of Platonic solid. V minus E plus F has to be 2. And it's true for the cube. It's true for the tetrahedron. The number of vertices, well, on a tetrahedron, 1, 2, 3, 4. There are just 4. And then the number of edges, well, the number of edges, you got 1, 2, 3, 4, 5, 6. And then the number of faces on a tetrahedron, it's a triangle dice, so there's 4, and that does equal 2. So we know that the number that a tetrahedron can be a Platonic solid, and that's true for all 5 of these things. But what we don't have is any way, and it can be proven, it's beyond the scope of our course, we don't have any way to generate a new kind of Platonic solid. If you get the number of vertices and the number of edges right, the faces go wrong. If you get the number of faces and vertices right, the edges go wrong. And so you try other possible combinations of vertices, edges, and faces, and they just don't work together geometrically to give a three-dimensional shape. So we know that we know that we know that these are the only 5 Platonic solids in the world. There cannot be another. Well, I hope that that is helpful to you and that it gives you something good to think about before we gather in class.